ஆம்ஸ்டாங் சார்.
சொல்லுங்க.
மகேஷ் சார் வந்து இன்னும் இந்த லிங்க்ல வந்த மாதிரி தெரியல.
பப்ளிக்
மகேஷ் சார் இன்னும் இந்த லிங்க்ல வரலையே. சரி, நான் பிரின்சிலுக்கு நான் கால் பண்ணி சொல்றேன், லிங்க் அனுப்பி அதுல வர சொல்றேன்.
பேசிட்டு சார் ஸ்க்ரீன் விசிபிளாக இருக்குல்ல, நான் இங்கே உள்ளது. அதான் கேட்டேன். இல்லை நான் ஸ்க்ரீன்லேருந்து வரதை கேட்குறேன். விசிபிளாக இருக்குன்னு இருக்கேன். இல்லை நான் செல்லில் பேசுகிறேன். போட்டு தான் இருக்கேன். நம்ம எதுவுமே டிஸ்டர்ப் பண்ணல. அதை தான் கேட்குறேன் கன்ஃபர்மேஷன். ஏன்னா எனக்கு கன்ஃபர்மேஷன் தான் இருக்கு. ஓகே. அவருக்கு ஃபோன் வச்சு கேட்கணும். சரி.
Hello. Sir, can you able to hear my voice? Hello. Sir, can you able to hear my voice?
Yes.
Hello.
Hamstrung, sir.
Yeah, tell me.
Rajasekar, Mr. Rajasekar, resource person.
Oh, want to admit? Definitely.
Yes, yes.
Sendil, sir. Hello.
Yes, Rajasekar.
Sir, you can hear me, right?
Yes, 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 sir.
Yeah, okay, thank you, sir. Thank you, sir.
அப்புறம் மகேஷ் கொஞ்சம் வெயிட் பண்ண சொல்லுங்க. இல்லை ஸ்டார்ட் பண்ணுறேன், வெயிட் பண்ண சொல்லுங்க.
Bensley sir, shall we start?
Yes, sir.
Okay.
சொல்லுங்க. ஆமாம், ரெடி பண்ணுறேன்.
Good evening, distinguished guests, including respected professors, academicians, research scholars, and students. We extend a warm welcome to the second day of our 5-day online faculty development program on exploring the frontiers of computation, formal languages, and automata. It is our privilege to have you join us today. We are pleased to introduce our esteemed speaker, Mr. R. Rajasekhar, ME, doing PhD, Assistant Professor of Computer Science and Engineering. Today's session will explore the Rijk method in automata theory, a groundbreaking approach transforming our understanding and analysis of automata systems. It is our pleasure to introduce Mr. R. Rajasekhar, ME, doing PhD, a distinguished assistant professor in the Department of Computer Science and Engineering at the School of Computing, Kalasalingam Academy of Research and Education. With an impressive academic record, including securing the 4th rank in ME from Anna University, Mr. Rajasekhar brings 12 years of academic experience to the table. A renowned expert in theory of computation and compiler design, Mr. Rajasekhar has also completed certification courses in data science, machine learning, and deep learning. His research interests lie in machine learning, deep learning, and data science, with a notable publication record that includes 2 books chapters, 19 international conference papers, and 7 international journal papers. May I request all the participants to kindly mute your microphones during the chief guest presentation to avoid any background noise and ensure a smooth session. Thank you for your cooperation. And now, without delay, I am pleased to hand over the session to our distinguished speaker for today, Mr. R. Rajasekhar. Please join me in welcoming him. Sir, the floor is yours, sir. Please, sir.
Yeah, thank you, sir. Thank you for your warm welcome.
Thank you, sir.
Yeah, okay, sir. I think I'm audible, right? Is there any other noises is there?
Sir, audible, sir. Very clear. Clear.
Okay, sir. Okay, thank you. Shall I start the session, sir?
Okay, sir. Sir, your slide is not visible to the participant.
Yeah. I'm going to share it, sir. Okay.
Okay, sir.
So I hope it is visible, right?
Yes, sir. Now visible, sir.
Yeah, okay. Thank you, sir.
Thank you, sir.
Yeah, good evening, one and all. Myself, I'm Rajshekar, assistant professor, Department of CSE from Kalasalingam Academy of Research and Education. It is a great pleasure to deliver you the lecture about exploring Rij method in automata theory. Okay. Okay. Before going to this Rij to the power k method, actually I want to recollect some of the basics things. That is, what do you mean by finite automata? And we need to talk about what is regular expression. I think Vallirati ma'am yesterday she has covered all those topics. With a quick recap, I will go with the finite automata and regular expressions. So actually, what do you mean by finite automata in sense? So it is going to accept a set of all strings in the language, and it tells whether the string belongs to the language L or not. Actually, you can able to see the diagram. It seems so. So I'm going to give a set of all strings as input to this finite automata model, and your model is going to tell whether the string which is belonging to the language or not. If it is belonging to L, that is said to be accepted, and if it is not belonging to L, it is said to be rejected. So that is the thing it has shown clearly in the diagram. Actually, we have a tool that is JFlap, which will show you the explanation of this. Let us move to the next slide. Okay. Now I want to recollect this basics things. You want to understand that is symbol, alphabets, then string and languages. Now only then you can understand what is an automata. So there is a question, see, construct a finite automata for the language L that accepts set of all strings whose length is exactly 2 over sigma is equal to a comma b. Here, the sigma is equal to a comma b is called as alphabets, and separately this a and b are said to be symbols. And what do you mean by alphabet means? If I'm grouping this symbols a and b together, that will constitute an alphabets. And what is a string in sense? See here, they have given a question. We need to generate the set of all strings whose length is exactly 2. So they have given the input a comma b. Using this a comma b as an alphabet, I want to generate a 2-length string. What are the strings it is possible? So in the string, I can generate with the help of AB, I can generate AA. It is 2-length. And next I can generate AB, that is another 2-length. And next BA and BB. So there are 4 strings. What are the 4 strings? AA, AB, BA, and BB. If I'm combining all the strings together, that will form a language. Now, I will go to the previous slide, you can understand. So now I'm going to give the strings in the language. So here, what are the strings in the language? 4 strings are there, right? AA, AB, BA, and BB. Now I will be giving this to the model, and the model will tell whether this string is belonging to a language. If it belongs to the language, it is said to be accepted, or it is said to be rejected. Okay. So now I'll show you the model of this. So the entire thing I want to show this. So this is the model. So the model will constitute a state and the inputs over the edges. So always your model is going to start with a state. That start state is called as Q0. And what is the first input I have? AA. So I have shown you this diagram with an arrow mark, right? In the right hand side, you can able to see. See, first I am in the state Q0. So for first A, you can able to see the input below. This is now the start state is Q0. The input tape is there. There I have shown the input AA, right? Now from the current state Q, for the input A, it is going to the next state. What is the next state here? Q1, right? And now you can able to see that below. See, this first A is becoming unbolded. That means I have processed that A. Now I am in the current state Q1. Now, what is the next state? What next input it is there? The next input is another A, and now the current state is Q1. So you can able to see that in the window in the second diagram. So Q1 is my current state. Now A is the second input, and from this I am going to the final state Q2. So if any string reaches the final state, then that is said to be accepted. It is shown in green color, right? So that's what in the first slide we have seen, see, accepted by automata by moving to the final state. So if any of the string moves to the final state, that is said to be accepted. That is shown in green color. And if any of the string is not accepted, that is shown in red color. Okay. So that's what we have shown. So here it is becoming green. So why it is Q2 is double circle means if any state is with a double circle, that intimates it is in a final state. So this is a model here. What do you mean by model in sense? This entire diagram Q0, Q1, Q2 is there, right? That is the model which is called as finite automata. And what is the input to this model? We have a strings. What are the 4 strings of this model? Already we have discussed here. A, B, BA, and BB. These are the strings given as input to this model. And we are going to get the output, either it is accepted or rejected. I hope it is understood, right? Finite automata. What do you mean by a finite automata now? Now, this finite automata is going to, similarly, we have given some problems. See, construct a finite automata that accepts set of all strings whose length is at least 2. Now, if I want to construct the automata at least 2 means, can you tell me what is the language? I'll go to the board. For example, my language is, it is at least 2. At least 2. What is over the input alphabets? What sigma is equal to A comma B. Now with this, what are the string that I can form with at least 2? So minimum I need to have 2 length string. Maximum I can have any length string. So the minimal string is AA, AB, and BA and BB, right? And what are the other strings? I can also form 3 length, triple A, triple B, or ABA, anything. It can be 3 length, 4 length like this. It will be keep on going on. So how can I draw an automata? So first I need to start with the start state Q0. Now I need to take the minimal possible string. What is the minimal possible string? A. So first, for first character, I am moving to a new state. Then from Q1, now current state will be Q1. From that, I am going to take the second input A, and it is going to be the final state. Why it is in final state? Because this string AA belongs to the language, right? Now same way you can try the second string. So first string A, so for Q0 A, it will go to Q1, and next input is B. So I can create a B transition for this. So it will go to AB. Now another thing BA. So from Q0, whenever I'm taking a new string, again I need to start from the start state. So first B. So I'm going to take B transition from Q0 to Q1. Then already A is there. So it will go to the final state. So these strings are said to be what? Accepted. Similarly, BB is accepted. Now I want to check for triple A. So what is the possibility here? From Q0 A, I can go to Q1. Then from Q1 A, I can go to Q2. Remaining, see, the minimal string is 2. But I can accept any length of the string. So if I'm taking any length, that can be given in the self loop. So either any number of A comes or any number of B comes, I'll be in the same state. So clear? Can you able to understand this diagram now? So triple A, first A, second A, it will go to Q2. Third A, it will be in Q2 itself, which is the final state. So it is moving to the final state. It is in the string. The string is in the language. Similarly for B, first B, it will move to Q1. Second B, it will move to Q2. And third B, it will be in Q2 itself, right? So now, let us move to the slide. So this is the example workout I have given. Now let us move to the regular expression. So what do you mean by regular expression means? It is also going to accept regular language. That means, see, what do you mean by regular language in sense? So regular languages are generated by regular grammar. So it remembers only the current state and current input. Whereas it cannot remember what is my previous state and previous input. As coming to this whiteboard, you can see, if I'm moving for Q0 for A input, it will move to the state Q1. When I am in the state Q1, your finite automata can never remember what was the input it was read previously or what was my previous state. That is the main drawback of your finite automata and regular languages, right? So if I'm representing a regular language in a diagrammatic representation, that is called as finite automata. Same way, I can represent my regular language using an expression. That expression is called as regular expression. Okay. So due to lack of memory, your finite automata has no memory. So it cannot remember what is my previous state and as well as what is my previous input. Is it clear? So now there are some operations of regular expressions. So first operation is union. So already we know if I want to, there is a diagram given side by side, right? For union, either I can move for A or I can move for B. That is the meaning of union. So it is intimated with the symbol that is plus. So here I am showing it, right? So 1 minute. Yes. Here union, either I can use plus or I can use a pipeline symbol. That means that either or. That means so I am having an automata here. See, from Q0 for the input A, I can move to Q1, or from Q0 I can move for the input B to Q1. So how can I represent that? Either A or what? Plus B. This plus indicates or union. Similarly, I can also move for B. That is why I have written the regular expression as A plus B. If I want to represent the same thing in the form of diagram, I have shown you the diagram parallelly here. So Q0, AB, Q1. Now, what is the next operation is concatenation. So what do you mean by concatenation? The meaning of concatenation is followed by. So for example, I have written the regular expression for A followed by B. So dot represents followed by B. So A should be followed by B. Then what should be my finite automata? So from first Q0 for A, I am moving to Q1. Then it is followed by what? B. So this is the diagram. So if I am having the transition one after the another, that is called as my concatenation. If I am having the transition in the same inputs, that is from Q0 to Q1, either I can go for A or in the same transition I can go for B, but I can never ever go for A, B together. That is the meaning of this union and concatenation. I think you can understand this diagram clearly. Now, what is a closure in sense? So there are two types of closure, clean closure and positive closure. See, if it is clean closure, that is going to take 0 to n possibilities. For example, I have taken my input set as A. If I'm giving a star, that means that it is clean closure. So the star, A star means the star I can replace for 0 to n possibilities. If I'm replacing star by 0, it will generate no strings. Don't see in the perspective of mathematics. See, if I'm substituting A to the power 0, by mathematics you will be getting 1. But according to this formal language automata, if I'm giving A to the power 0, it will generate null string. That means the first input is null. So if I'm substituting star as 1, you will get single A. If I'm substituting star as 2, you will get double A. Likewise, it will be keep on going on. That is called as clean closure. So clean closure means 0 to n possibilities. Whereas positive closure means a minute change. Instead of 0, it will start from what? 1. So null will not be there in positive closure. So can you able to understand this operation and what is regular expression now? Okay. So before going to this Rij to the power k method, you need to understand this precedence rule. So which operation, if I am having, see, a single expression can have all the operation. For example, it can have union, it can have concatenation, or in a single expression, I can also inculcate closure, right? If all the operations are given in a single expression, then we need to know which operation I need to evaluate first. That is called as what? Precedence rules of regular expression. So first, I need to evaluate the expression which is given in the parenthesis. Then it should be followed by clean closure. Then after that, I need to evaluate if there is any positive closure. I need to evaluate after clean closure. Then question mark means it is 0 or 1 occurrence. Plus means 1 or more occurrence. Star means 0 or more occurrence. Then after evaluating the closures, then I need to evaluate concatenation. Then after concatenation, finally, I need to go with union. So this is the order. So how to evaluate the expression? First parenthesis has to be taken care. Then I need to take care of the closures. In that closures, I have the clean closure, positive closure, and then it is question mark, it is 0 or 1 occurrence, right? Then after that, I need to evaluate concatenation. Finally, I have to go with what? Union, right? So this is the thing I have given in the table, the same thing. What is the precedence order, how to evaluate? So now I have to tell you how we are constructing a regular expression from the automata. So you know what is regular expression now? So regular expression is the simple expression of your regular languages. both your finite automata as well as your regular expression is going to accept what language? Regular language. So regular language in sense, I want to tell you. So here I have given you some examples. See, modulus w is equal to 2. This is the language already we have seen, a comma b. What is the language of modulus w is equal to 2? So you'll be getting a, that is I'll be telling you. So here you are going to get double A. If modulus w is equal to 2, I have to get double A or AB or BA or BB. So by seeing the automata itself, it is very clear. See, if I'm moving from Q0 for input A, I'll be in state Q1. So whenever I move to Q1, your finite automata may not remember what was the previous input it is read and what was the previous state. So hence, this is not needed. I don't want to remember any previous input according to this language w is equal to 2, because only for first year I'll be moving to Q1. If I'm getting second year, I'll be moving to the final state. So in this case, I don't want to remember my previous input A, right? So but see the second language, I need to, that is A power n and B power n. So here what is the language intimates? So equal number of A's which is followed by equal number of B's. So for this I can never ever draw an automata, because I want to keep the count of A's. If I'm reading B's, I want to know how many A's I have read so far. For example, if my n value is equal to 2, then your string will be what? It will be, if n is equal to 2, for the second language, it will generate double A and double B. So if I'm started reading B, I want to keep the count of number of A's I have read so far. So this finite, if I cannot construct the automata, because your automata has to remember how many A's it has come across. So it is not possible with regular languages. A power n and B power n is not a regular language. So same language for the modulus w is equal to 2. This automata already we have seen. So this automata, how we are constructing it to a regular expression. That is the from Q0 to Q1, what are the inputs it was there? Either I can go for A or I can go for B. That is why I have written A or B here, this first regular expression. Now, if I am having a followed transition, so the follow will be given as what? Dot. That is mean by concatenation. And again from Q1, either I can move for Q2 for A or B. So again it is what? A or B. Now this will generate the same language. See, if I am multiplying A and A, you will get AA. Okay. See. Again, for I think I'm audible, right? Sir?
Yes, audible.
Yeah. Okay. Now, see, first, if I'm multiplying A and A, I'll be getting double A. Again, if I'm multiplying A with B, then it will generate the string AB. Then B and A, if multiplied, it will get BA and finally BB. So this is the regular expression for the given automata. How it is constructed? See, from Q0 to Q1, we have A or B. So that is written as A plus B, and it is followed by another transition AB. So followed means we need to keep concatenation, that is dot, and the next transition, what is my next transition? Either it will go for A or B. So A plus B. So now can you able to understand what is finite automata and how we are constructing a regular expression from the automata, right? So next I have given some workout. See here, this is the automata we have constructed for that at least 2, right? See here, at least 2 is, this is the automata we have already constructed. So what will be the thing it is there? So see here, first transition is A or B. So first I can write A plus B. Then again we have one more transition, right? So I need to keep dot. Here also we have A comma B. So I need to write A plus B, right? For this. And this we have A plus B here. And this we have A plus B here. Because this is a followed transition. So I am concatenating with dot. Now again in the self loop. See, if it is a self loop, already I have told you in this slide, right? So you can see the slide. See how we have represented the self loop. So A star means it is what? It is self loop means I can write it as A star. So same way in this diagram also we have a self loop here. So this self loop again it is followed, right? So I have to write it as A plus B and I need to give a closure because it is a self loop. Whenever it is a self loop, I need to give a closure. So this is the regular expression for the given automata. So what is the regular expression? A plus B followed by another A plus B, then followed by another A plus B whole star. Now this will generate any language. So you can, if I want to get minimum 2-length string, so this will generate double A and AB, then it will generate BA, then next it will generate BB. Then if I want to generate 3-length string, see, already we have 2-length string for this. Then if I'm multiplying any a, so minimal possible string is 2 length. So if I want to generate 2 length, this star will be 0. So this will not be generated. If I'm substituting 1, it can generate. So for a, if I'm adding one more a, it will generate triple a. Like this, it will be keep on going on, right? So I hope you understand this. I'm moving to the identity rules. So now we are into the topic of Rij to the power k method. Before going to this Rij to the power k method, you need to understand this entire properties. So among this, which is the property which is very important, we will be often using in sense 1, 2, 3, 4, 5, 6. We will be using that. Then 9, 11, 12, then 13, 14 and 16. These are the properties we will be often using it. Now, this is constructed based on the regular expressions. So I'll tell you how. See, null into regular expression, it is going to define what? The same regular expression. So I'll show you with this next diagram. See, the first property, if I'm constructing the regular expression, see, q0 to q1, lambda means it is null. So followed by r, finally, which is going to the final state? For r, it is reaching final state. So we have written null into r as what? R. Now, second is null closure. So if it is closure, how we will write it? So closure means for this star, I can substitute 0 to n possibilities. So if I'm substituting 0, you will get null again. If I'm substituting 1, you will get single null. So null closure again, it will yield what? The null alone. Now, what do you mean by pi means? So you want to understand the difference between null and what? Pi. So null means from q0, if I'm in particular state, I will be moving for null to other state. But if it is pi, if I am in a particular state, you don't have any transition to the next state means there is no input or no null transition. So that means it is pi. So if there is no input at all, I cannot reach from q0 to q1. That is the meaning of pi. So I have given pi closure is again, it is going to give what? Null. Because for any closure, the first string generated is what? Null. So again, it will generate null for pi closure. Right? Then pi into r. What do you mean by pi into r means? See, pi, it doesn't have any transition at all. But from q1 to q2, we have r. So pi into r, only if I reach q1, I can reach the final state, right? But I can never ever reach q1 because there is no transition at all. If no transition is there, that is intimated by what? Pi. So finally, I can never ever reach the final state. So pi into any regular expression, it will give you what? Pi. That is the rule. Now pi plus r means, so this is the thing, pi plus r means, so it is going to give you what? R. Why? See, this is the diagram for R. So either I can go for, so this is pi because it doesn't have transition. So one starting state is there, and from starting state, I can reach Q5 either through this path or I can reach through this path. See, for pi, I can never ever reach Q2. So only path I can reach to the R. Again, we know null into R, it is going to give R. So R into null also, again, it will give you R. So pi plus R, it is going to give you what? R. Then this is R plus R, I have already told you. This is either I can reach the final state through above path or by this path. This is also accepting R. The second path is also accepting R. Finally, what is the language it is accepting? R. So R plus R is R. So this is the thing I will be telling you. Then I will be telling you this while I'm solving the problems. So these are the properties. It is very, very important. Now coming to this Rij to the power k method. So what is the purpose of this Rij to the power k method is, it is going to convert my finite automata to regular expression. Is it clear? So for that, we are going to use this formula. So don't panic about this formula. I'll tell you how to remember this formula with the help of this diagram. So we are going to take a random states. One is state I and state k and state j. Here we are going to consider this qj as my final state. So that's what I have made it as a double circle. And the starting state will be what? Qi. And some other state, intermediate state is qk. Is it clear? So now I want to make you understand this formula. See, what is this formula intimate in sense? See, I can reach the final state in two paths. Either I can reach from qi to qk, then I can reach qk to qj, or directly I can reach from ij. So that is why they have kept union here. You can refer this formula. See how I am making this formula to understand in sense. What is the first state? I. So here each R is representing the regular expression that is generated for that particular state, right? So now what is the Rij to the power k method? So the formula is, first we are in the state I. So this I represents what? state from. So which state it is? Now I am in the state Qi, and J represents which state I am going to. Now see here, I to K. Now if I am in the state Q, first I am taking this path, right? So this path I am going to take Qi, Qk, and Qj. Now that is the thing this is representing here, right? Now first I am in the state I, then I am reaching which state? K. Always to the power I need to substitute K minus 1, right? I will tell you why later. Then which is followed by, so here it is a concatenation. What is the next state? Now I have reached state K. Again, I am going to reach state K with what? Self loop. If there is a self loop, then I need to give this closure. So that is why in the second expression, it is closure is there. Then again from K, I can reach what? Which is followed by, so dot and K to J, or Kj to the power K minus 1. This is one path, or I can directly reach what? Final state from I to J. So Ij to the power K minus 1. So this is the way to remember this formula. Here R represents the regular expression. I is the state from where it is source state, and J is the state which is going to which, what is the next state, and K represent total number of states. According to this diagram, what is the total number of states? We have 3 states. So we need to compute based on this. So I'll tell you clearly in the problem whatever I'm having. So now let us see this convert the given finite automata to regular expression for this first example. Okay. So now I will go to a whiteboard there you can understand how I am going to. Okay. Can you able to see my whiteboard?
Yes.
Yes, sir.
Okay. Thank you. Okay, now let us move to this example. So I hope I'll write the formula once again. So R I J to the power K. This is the method we are going to see that. So what is the use of this method? I'm going to convert a given finite automata to what? Regular expression. So how I'm going to convert in sense using this formula. So what is the formula? R Ij to the power K. So is equal to, remember this diagram. So first I am in the state I. So what is the next state I can reach? K. Then to the power K minus 1, which is followed by, what is the next state? K. So R, K, it is going to K itself. So K minus 1, because it is a self loop. So I'm adding a closure here, which is followed by R. What is the current state? K. What is the next state I can reach? J. So to the power K minus 1, right? This is the one way to reach the final state. What is the other way? R. So other way means I need to keep union. So plus R, directly I can reach from I to J, K minus 1. Am I right? So the problem we are going to see this, the first state is Q1. And from this, I'm going to 0 for the next state. Let us assume this is Q2, which is the final state. And if any number of zeros comes, R1 comes, I'm going to be in the same state. Now, by seeing this diagram, can you able to tell me what is the regular expression we will obtain for this? Can anyone?
Zero, 1 star.
Yes, sir. 0, which is followed by, because dot will be there, then we have a self loop, right? So either it is going for 0 or it is going for 1, because it is in a self loop. I am going to give what? 0 plus 1 star. So this is the thing we need to get it. Or directly I can go to the final state. Either it is going to 0 for the final state, or for 0, after getting 0, I can get any number of zeros or 1. So this is my regular expression. So I need to obtain the same regular expression using this formula. So let us see how we are going to obtain this. So first we want to take here, I already have told you K represents what? Number of states. Here how many states are there? 2 states are there, right? So then what I need to find? Rij to the power 0 I need to find. Then Rij to the power 1 I need to find. Then finally I need to find Rij to the power 2. So this will give you the regular expression of the exact answer whatever I have written. Okay, now let us move to the first step. Okay. So first I'm going to take so you remember this diagram. So Q1, so 0, Q2. So this is my final state. I am going to give 0 or 1. So this is my diagram for which I need to find the regular expression. So first I am going to start the solution. So first when I need to take when k is equal to what? 0. So if here the k is equal to 2. So I need to find it for k is equal to 0, then k is equal to 1, then I need to find it for k is equal to 2. So first I am going to take k is equal to 0. What do you mean by k is equal to 0 means? So now I'm not going to consider any states. So if I'm taking a particular state, what is the input to that state? That alone I am going to find it. So first so what is this here? Two states are there. This is first state, this is second state. So first, is there any transition, any input from the state 1 to 1? See,
No.
if I value and j value are there, same, that is I is 1 and j is 1. If I is equal to j, then I can reach the same state through the input what? Null, right? But according to this diagram, R11, it doesn't have any other input. So since I and j, so this is I, this is j. Now k values, I'm going to keep it as 0. So I value is 1, j value is 1, k is what? 0. So R110 is, what is the input it is there? No other input. So I can keep null because I and j are what? It is same. Now what is the next state I can find? So now I am in the state 1. I can reach what state? 2. So I value is 1, j value is 2. So k values now we have kept it as 0. So what is the thing? R12 is there any transition for R1 to 2? Yes, we have what?
Transition.
So, right. So 1 to 2, I have 0. Now next what I can have, what is the next thing I can find? Is there any transition from my I value? If my source state is 2, is there any transition to 1? So 2, 1 to the power 0. So I value is 1, j value is 2, k value is what? It is 0. So now 2 to 1, is there any transition?
No.
No. Then what should I keep? If there is no transition, what does it mean? It is
Then it should be
integrated by what?
Pi.
Pi, right? Pi, because there is no transition at all. So I need to keep it as pi. Now what is the next possibility? My source state is 2
to 2.
and is the
Yeah.
2 to 0. So I value is 2, j value is 2, k value is what? 0. So now 2 to 2, what is the thing we have?
0, comma 1.
R, so comma 1 means either it can go for 0, I need to write it in a regular expression
0
because
plus 1.
every R is represented as yes, good. 0 plus 1, right? So that is the thing. So now this is when k is equal to what? 0. Now what is the next thing I need to find when k is equal to what? 1. So I am going for next thing when k is equal to 1. So now next thing is I am going to find it for what? When k is equal to 1, right? Now that means that consider only one state at a time. Consider only one state, right? So now if I am going to do it for k is equal to 1, what is the formula? Did you remember the formula Rij? In the k is equal to 0, we have not used any formula because I'm not considering any states. Now for k is equal to 1, I'm going to consider single state, right? So I need to use this formula Rij. What is the formula? Can you tell me the formula? Did you remember? I k to the power k minus 1, which is followed by R k to the power k minus 1 whole star, right? Then which is also followed by k, my current state, next state is j, k minus 1, right? R directly I can reach from I to j. So ij to the power what? K minus 1, right? Now again I need to find it for 4 values. Now first thing is R11. Now k value is what? 1, because we are going to take k value as what? 1. So I value is 1, j value is 1, k value is what? It is 1, right? Now what should I do here? So I value is 1 means now I want to apply in this formula. So R, what is I value? 1. K value is also 1. Now k minus 1 means already we have taken k is 1. So minus 1 means it will become 0. So what does it mean in sense? We have already computed k is equal to 0. Whenever I'm computing k is equal to 1, we are going to take the output of the previous step. That is the meaning here. So which is followed by kk. So what is k value here? 1. Again for this k I'm substituting 1. So k minus 1 it will become 0, right? Followed by rkj. What is k value? Again it is 1. Then k value is 1. It is 0. K minus 1 plus rij. I is 1, j is 1, k is 0. Now we know this, right? For example, I'm going to here. What is R11 to the power 0?
It's silent.
Right? It is epsilon, right? So it is epsilon means, so what should I do here? First, I need to substitute that. So I'm taking some other thing. Okay. So now for R11 it is null, right? Okay. R110 it is null, followed by what? R11 0. So again it is epsilon
Star.
closure, then star. Again it is R110, the same value null, followed by R11 is epsilon. Now how to evaluate this expression? I have told you the precedence, right? Can you tell me what is the precedence? First I need to evaluate what? Bracket. Then I need to evaluate star. Then I need to evaluate plus. This is positive closure. Don't think it is union. Then I need to evaluate concatenation. Finally, I need to go to what? Union. Right? This is the precedence order. So according to this, here which I need to evaluate first? I need to evaluate this parenthesis, right? So already we know what is null closure. So null closure is going to give what? Null. So this is null into, again it is going to give null plus null. So what is the property I have used? Null closure is what? Null, right? Now it is 1 minute.
Right.
I'll minimize. Okay. Okay. Now, so this is the property I've used. Now, what is the meaning? Null into any regular expression, because null itself, it is a what? Regular expression, right? So null into regular expression, that is the thing. So here now we have evaluated that is parenthesis and closure. Next, I need to evaluate what? Concatenation, because we don't have positive closure. So concatenation. So null into any regular expression, it is going to give what? Null. So null into regular expression, it is going to give you the regular expression. Regular expression is again null. Right? Then finally we need to evaluate. So null plus R plus R. You know the property R plus R is equal to what? R. So null plus null, again it is going to give what? Null. So R11 to the power 1, it is going to give what? Null. Can you able to understand this? Now what should I find next? What should I find next? I need to find next is R12, right?
K is equal to 1, 2. Yes. K is equal to 1.
Value is 1, J value is 2, K value is what? It is 1.
1.
Now what is the formula? Rik. So I is 1, K is 1. So K minus 1, it will become 0, followed by it is RKK. What is K value? 1. Again, so R11, K minus 1, 0. I need to keep a closure here according to the formula. Then it is followed by KJ. What is K? K is 1. Then J is 2, right? Then it is 0. K minus 1 plus again Rij. I is 1, J is 2 to the power 0. Now everything, this you know, it is null. Then again for R110, it is null. Then R12. What is R12? Already we have computed here, right? So what is R12 here? R12 is 0, what? 0, right? So here it is there. R12 is, this is the thing, right? R12. So now R12 is, it is 0. Now I'm going to take it as what? Followed by 0, then plus what? 0. Now how to evaluate this expression first? First I need to evaluate what? Parenthesis. And this parenthesis of closure is there. So according to that, null closure will give you what? Null followed by 0 plus 0. By what rule? Null closure is what? Null. And next I need to evaluate what? Concatenation. So null into null, it is null. Again null into what? 0, it will give you what? 0 plus 0. So this is according to which property? Null into R is equal to what? R. Now what is the next property? R plus R. So it is either going for 0 or 0. So finally it is going for what? 0. So this is R12 to the power what? 1. Can you able to understand this? So this is by property R plus R is equal to what? R. Clear? So now we can, what is the next thing I need to find?
2, 1.
I need to find, yes, I need to find R21, right? 21 to the power 1. So I value is 1.
Right.
And J value is, sorry, I value is 2, J value is 1, K value is what? 1. So according to the formula Rik, I is 2, K is what? 1. So to the power 0 followed by RKK. So K is 1, KK 1, 1. So 0 to the power closure followed by what? RKJ. K is 1, J is also 1 to the power 0. R what? Rij. I is 2, J is what? 1 to the power 0. You know 2 to the power 1, you don't have any transition at all. So did you remember this diagram? Q1. So here it is 0. Q2. Here we are having 0, 1. From Q to 1, there is no transition at all. So that is 2 to 1 is what? It is 5. Right? So it is followed by R110. Already we know that is what? Null. Then closure followed by, again it is null. R21 is, again it is what? pi.
Fine.
So here, according to the property null closure, what is null closure? First, I need to take what? Evaluate the closure first. So pi into null closure, it will give you null and null plus pi. So which property I have used? Null closure, right, is equal to null. Then pi into regular expression. You know that pi means q naught. So next we don't have any transition to q naught. Then only we will be giving pi. So if there is pi, then pi into any regular expression, it will give you what?
Fine.
This pi itself. So
Pi.
the entire expression is pi after. So this will become pi, and this is pi.
Plus.
So this
Okay.
is pi into this. So finally, r plus r. R is pi is also a regular expression. So pi plus pi is what? It is again pi. So this is by r plus r is equal to what? R. So r21 is what? Again it is pi.
Fine.
Can you able to understand this? Yes.
Yes.
Yeah. Next, I need to find what is the next thing I need to find? R22, right? So I need to find R22. So next I'm finding R22 to the power 1. Now what is the I value here? 2. J value is 2. Value is what? 1. So according to the formula, Rik is first. I is 2. K is what? 1. To the power 0. K minus 1. So K is 1. K 1 minus 1 will become 0. Followed by R Kk. K is 1. K is again 1. So 0. K minus 1 is 0. And to the power closure. Followed by Kj. What is K here? 1. J is 2. Right? Then it is 0, power 0. Or I can reach Ij directly. So I is what? 2. J is also what? 2. Right? To the power 0. Now according to the diagram, 2, 2 is what? R22 to the power 2 is 0 plus 1. Right?
0 plus 1.
So now R21 is R21 to the power 1 is what? It is pi. We have calculated in the first step. So that is pi. Now which is followed by R11, you know, that is null closure. What is R12? R12 is, it is 0, right? So R12 is 0 plus again R22 is 0 plus 1. Now what I need to evaluate first, because you know pi into any regular expression, it will become what? Pi. According to that property. Even if I am taking this property, it will give you null. Then again we have pi. Pi into any regular expression, it is again going to give what? Pi. So I am substituting this as pi here. Plus remaining what you have? 0 plus, right? So now what is the, so pi plus r. It is going to give you what? R. So again we can write it as 0 plus what? 1. Right? So R221 is what? It is 0 plus 1. Is it clear? So now we have computed the step k is equal to 1. What is the next step I need to find?
K is equal to 2.
K is equal to 2. Yes, good. Now we need to go for, because maximum how many steps we have? 2. Now when k is equal to 2. Now what is the meaning of k is equal to 2? Consider
Both the states.
at a time. 2 states at a time, right? So now what is the meaning there? If I'm see now, is there any other state k is equal to third state is there? No, right?
No.
So I don't want to compute R11, R12, R21 and 22 because after this we don't have any states. If I'm having states, then I need to compute all the things. Now this is the final k value. So what I need to do, I'm going to take only the final state where I can reach. So did you remember this diagram? Q1. So for 0, I am going here. What is the final state? Q2, and this is 0, Q1, right? Now, how can I reach the final state? From 1 to what? 2. It is enough to find 1, 2 to the power 2. That alone it is enough. So it will give you the entire regular expression. Is it clear? So other things I don't want to find. R11 I don't want to find. R21 I don't want to find. R22 also I don't want to find. How I am reaching the final state? R12. So that's why I'm taking that alone. R1 to the power 2, right? So if k is, if I'm having one more state like q is equal to 3, then I need to find all this R11, R12 and everything. But here we don't have third state, so I'm completing with the second state. That's why, which is the final state, which way I'm reaching the final state, that state alone I'm computing. R12 to the power 2. Now what is the formula for this?
Rij.
That is Rij means here I value is 1, J value is 2, K value is what? 2. Ij means Ik, right? First Ik. I is 1, K is 2.
K is
So
2.
2 minus 1, it will become what? 1 now, according to the formula. Followed by RKK. What is KK? So 2, 2, A is 2, 2 to the power 1. So
1.
closure. Then
Closure.
it is followed by RKJ. K is what? 2. J is what? Again 2 to the power what? It is 1. Then plus IJ. So what is I value? 1. J value is 2. To the power 1. This is the thing I am going to find. Now, let us 1 minute. I will minimize this. Then I will write you. I hope you can see the input thing, right? So
Yes,
now
sir.
R11 to the power 1. What is the thing we have found? It is null, right? Again. So I will show you all those things. R12 to the power 1. What is the thing we found? It is 0,
It was
right?
0. Okay.
R21 to the power 1. It is what? Again, it is pi.
It is 5.
R
Yes.
2 to the power 1, we have found 0 plus
0
what?
plus 1.
1.
Yes.
This is the thing we have found when k is equal to what? 1. Right?
Yes.
So now we need to substitute these values. So what is R12 to the power 1? 0.
0.
Just followed by R22. So what is 0 plus
0 plus
1 whole
Closure.
star? Then what is R22? Again we have
0 plus
0,
1.
which is followed by 0 plus 1
1.
plus R12. What is R12? 0.
0.
Okay. Now I need to reduce this. So what is the formula to reduce it? How can I take this?
Evaluate parenthesis first.
First, I need to evaluate the parenthesis, right? So if it is parenthesis, whether any possibilities to reduce this parenthesis? No way, right? So if I'm not getting any properties, what I need to do in sense, see, here also we are having 0, here also we are having 0.
Take 0 out. Yes.
So we can take 0 as common. So if I'm taking 0 as common, so this 0 is multiplied
Plus 1 closure.
whole star, then followed by 0 plus 1. So for this,
That's
what I can
fine.
do then? Epsilon, right? Because
Epsilon.
null into any regular expression, again it is going to give what? The same regular expression. So for that I have given what? Null. Now, what is the property? Yeah, so we have one more property. So I will go to that particular slide. You can see that. So here, see, if I'm having null plus R star, can you able to see this property here? Ninth
Yes, sir.
property, null plus R star. What is the meaning there? R star, right? So shall I use that property here? See, here we are having null. So this is R and this is what? R star.
Yes.
So if it is null plus R star, what is the property I can write? R star directly.
Yes.
Again, I will minimize. So is equal to what I can do? 0, which is followed by what?
0 plus 1 star.
1 whole star,
Closure.
right? Yes.
Yes, sir.
This is the first property I can get it. So directly it is going for 0, right? So what is the expression we have? Now the expression is 0 or 0 plus 1 whole star. See, if I want to generate 0, so did you remember the diagram Q1? So this is the diagram, right? See, for 0 directly I can go. If I want to get 0, this star value will be what? 0. So it is going to 0 for final state. If I want to get any number of zeros or ones after that 0, then this value we can substitute, right? So the expression is correct. Can you able to understand this?
Yes, sir.
Yes, I hope, right?
Yes.
Yes.
So this is the problem with which is a string starting with 0, right?
Yeah. It is starting with 0 and it is ending with any number of zeros or what? 1,
Yes, sir.
right? Is any other doubts you have?
No, sir. That's clear.
Okay. If you have any doubts, others, you can ask me.
No, sir. Proceed.
Okay.
This is we got 0 into 0 plus 1 star condition.
Sir, ma'am, I couldn't hear you. Your voice is noisy. Can you get again once again?
Actually, sir, our regular expression is 0 dot 0 plus 1 star plus 0.
Means, ma'am, actually 0 plus 0 dot 0 plus 1 star, right? See, I want to get 0 means what will happen? For this value, if I'm substituting 0, what will happen? This will generate null. So 0 into null, again it is generating what? 0, no?
0. Yes.
That is why for this 0, we can take this expression as it is.
Okay, sir.
Is it? Actually, if you people are taking TOC, this is one of the important question which will be always asked in your end semester. Without this question, there won't be any question paper, I think so. Actually, I have done with only 2 states. I don't have time. Within 1 hour, I can complete this. Even we have 3 states that we can prepare. If time permits, I will take it later. Any other workshop, if it is organized, I can take the 3 states too.
Sure, sir. We would like to. Please.
Yeah, okay. Okay. And can you tell this what will be the output of this? For example, Q1, I'm getting 1. So Q2 is the final state. 0 or 1. Here I'm getting 0. Can you tell me the expression of this? Expression alone. Regular expression. For this diagram.
Sir, it can be 0 closure followed
0
by
closure,
1, then
yes.
followed by 0 plus 1 closure. 0 plus 1 ka whole closure.
Yeah, good. Okay. Yes, thank you. I think you peoples have got it. Thank you. Sir? Time. And I'll go with the applications, Rij to the power application, where we are using this application instance. Especially the first and the foremost application is first the compiler design. That is especially in lexical analysis. I think so many people are new to this session. They might only if I learn the automata, I can go with the compiler. So without learning this automata concepts, I can never ever understand anything in compiler. So this finite automata and regular expression, whatever we have seen, this will be used in the phase of lexical analysis. For example, if I am having if I want to recognize int as a keyword, so it will construct an automata like this. So for Q1 it will go to N, and for Q2 it will go to T, and for final it will be in the final state. So now INT it is going to your final state, right? Now using this, it will understand, your lexical analyzer will construct this finite automata and it will understand that int is a keyword. So like this model will be applicable in the lexical analyzer phase. Same way I can use in the network protocol analysis also. So if you people are in network, see packet filtering, you will be knowing whether this packet is a correct packet or it is a hacked packet, like that. For filtering the packets, we can use this automata and regular expression. Then obviously natural language processing. For natural language processing, so many applications is there, right? Now, if I'm speaking in one language, that language can be converted to other language. Or if I want to analyze what is the next word, if I'm giving a particular sentence, if I'm giving any missing word, what will be the next word, that can be done with the natural language processing. Then we have digital circuits design for switching and owning the circuits, right? Like sequential circuits, you will be using half adder, full adder, and everything. There we will be using this state diagrams, that is finite automata and regular expression. Then software verification, and finally pattern matching in search engines like Google and everything. So if I'm giving a keyword for rose, then your Google is giving you rose related images, right? How it is giving? By applying this pattern matching. What is the keyword it is there, how it is matched with, then related to that, it will bring all the images or whatever content, either document or anything, can be done with this process. That is the most application of this Rij to the power k method. I hope it's completed.
Sir, can you show the slide with 3 problems of 3 states?
Yeah, okay.
I just want to take a screenshot and I'll solve it by myself.
Okay.
Yeah, thank you.
Okay. Sendil sir? Mahesh sir? I hope I know who is in the meeting, organizers. Yes, Sendil sir?
Sir, Principal sir.
Yes. Sir?
Sir, please wait 2 minutes.
Okay, sir. Okay. So shall I continue the session for 10 minutes?
Okay, sir, you can continue, sir.
Continue. Third state.
Okay, I'll go with the third state then. Okay, can you tell me according to this problem, what is the k value here?
Sorry, 0, 1, 2,
We have
3.
3, right? So I need to find it for k is equal to 0, 1, 2, 3. So now, can you tell me for 3, what state I need to find? Okay, first tell me k is equal to 0. Now, what are the things I can write? R11 to the power 0, R12 to the power 0, R13 to the power 0, then R21, R22, then R23, right? Then I can go with what?
Same thing.
R
3, 1, 3, 2, 3, 2.
31, R32, and R33, right? So now can you tell me what is R110? So 11, is there any incoming inputs? Yes, it is coming for 0, right? 0 and I and j value are same. So I add what? Null. Because without any inputs, I can be in the same state, right? So now what is R12? What is the input that is going for R1 and 2? Yes, again what? 0.
0.
Now what is R13? Is there any transition for 1 to? Yes, what is the input? It is only 1, right? What is R21? 2 to 1, we have one transition, that is 0.
0.
And what is R22? So 2 to 2, we don't have any transition, but I and j are same, so I can give it as what? Null,
Exactly.
right? So what is R23?
It's
2
1.
to 3, we have 1, right? Then R31. So what is 31? So either it is going for 0 or it is going for what? 1. So I have to write it as 0 plus what? 1. Plus means it is 0 or what? 1, right? Why we are writing in the regular expression format? Because this R represents what? Regular expression.
Regular
We are
expression.
going to compute the regular expression for each states. That's what, right? Then R32, what is there any transition for, sorry, R31, sorry ma, it is not R31,
Yes, 3 to 1 is there is nothing.
there is no transition, right?
Yes, it
Yeah,
should be epsilon.
When I erase it, yeah, I'll be giving this. So it is pi. So from 3 to 1, there is no transition at all. So it is pi. Now 3 to 2 is what? 0 plus 1. And 3 is, again it is what? Same, I and j are same. So it is what?
Epsilon.
Null, right? So now we have computed for k is equal to 0. Right? Now what we should do for k is equal to 1? So first I'm going to R11 to the power 1. So the formula is I value is 1, j value is 1, k value is also what? 1. So the formula is R, I, k. I is 1, so k is also 1. So 1, 1,
1, 1, 0.
it will be 0, followed by kk. What is kk? So k is 1, it is also kk 1, so 0, closure, right? Followed by kj. So k is 1, j is also 1 to the power 0, plus rij. So 1, 1 to the power 0. So already we know what is 0 plus R110. So it is 0 plus null followed by 0 plus null. We need to keep the closure. Don't forget this closure. So even if I'm missing any of the operations here, I will lead to the entire wrong answer. So we should be very careful in computing Rij to the power k method. So again it is followed by 0 plus what? Null, and it is 0 plus null. Now how should I evaluate this? Which I need to evaluate first?
0 plus null out.
0 plus no whole star, right? So what is the, we have one property, right? Null plus R whole star. So you know R star, it is including what? Null only. So null plus R star can be written as what? R star. Both are same, right? Because in the R star itself, I'm having what? Null. So I write it as it is. So 0 plus null. So what is R here? 0. So 0 star. So again 0 plus null followed by what? 0 plus null. Right? See, until we are getting a single expression, we need to simplify it. Then only the final expression will be very clear and it will be crispy. Otherwise, we cannot able to understand what is the final expression it was, right? Now, what is the next property I can use here? I will go to the previous slides. You can check there, see what property will be applicable next. Shall we use this 12th property? See, R star null plus R is there, right? Now R star is what? 0 star, and this R is 0. Null plus 0 we are already having. That can be written as what? R star, right? So I'm going to this. So again, see here. So here 0. This is what? R star, and here I can take this as R plus what? Null. So now this can be reduced. Either I can take this or this, right? Both are concatenation only. So I can write it as plus null. Again 0 star plus what? 0 plus null. Again we have the same property. See, R star R plus null. So that can be written others. Yes. 0 star 0 plus what? Null. Now what I can do here? Can I simplify further? What is the other way I can simplify? See, here also 0 plus null is there, 0 plus null is there. So 0 plus null, I can take it as common, right? So this is 0 star plus what I can keep? It is null, right? So again, what we can simplify? Is there any other possibility apart from this? Can we use any other property?
Any other queries from participants? Okay, sir. This was the some kind of the, shall we write the-
Sorry, I was disconnected due to network issue. Sir, completed. Yes, you can go ahead. Sendil, sir?
Thank you all.
Okay, sir.
Sir. Okay, sir. Okay. We hope that today's session led by Mr. Sekar has given you a deep understanding of the risk method and its significant contribution to the field of automata theory. Before leaving the forum, please all the participants fill out the feedback form because it is considered for your today attendance and which will considered for end of the session will provide your certificates. We look forward to welcome you all again at tomorrow's session. Please arrive promptly to make the most of the presentation. Thank you once again for your enthusiastic participation today. Thank you all.
Thank you all.
Thank you so much, sir.
Thank you.
You actually cleared the doubts.